Welcome back to Advanced Java. This is the week 7 office hours recording. So today I want to talk about three main topics. Some of these came in from you guys' questions, and others are just things that I wanted to make sure to cover because I didn't have a separate video for it. So first off, I've got an example working more with the properties file and working specifically with the interface. So here I have a very, very simple example class. It implements the properties loader. So that's going to mean that I can call the default method properties and get this chunk of code to run for me. I don't have to do anything in my class that implements properties loader other than just call load properties. So that's pretty slick. Nice thing about default properties is that a lot of times, or default methods, is that a lot of times implementing classes will have the same behavior. So this allows us to put that code in one place and not end up having copy and paste code all over. But we can always override that behavior if we want to as well, just like overriding any other method in a subclass. So basically I'm calling that load properties method here and passing in a sample properties property file. And that sample properties file just has two things in it, first name and last name. So I'm going to use this to demonstrate sort of how you'll use properties in at least one case in the project, in that you're going to be concatenating together or trying to create a file path, right? So the output file path. And many of you in the earlier project just hard-coded that in, right? So we had some kind of path that was output slash, summary.txt or whatever. In this case, in project 2, we have two different properties that we're using. One is essentially the directory for our output, and the other is the name of the analyzer report that we want to create. So we're going to need to put those two things together. And the answer to that is concatenate those two properties together. Don't let properties scare you. It's really just a variable, right? So here's my variable name, and here's the value. We call this a key and a value, but you can kind of think of it as just a variable. It's another variable that just happens to be stored out in a property file. So hopefully that helps you kind of feel a little bit more comfortable maybe with a new topic here. So I'm going to start off by running this, and I'm just printing out the two values that are in that file, first name and the last name. So I'm going to go ahead and compile, and then we'll give that a run and see the output. So we've got the system.out.println, which is responsible for printing those two things out. So the next question is, well, how do I concatenate or pull those two together? So I might just grab the second properties and concatenate them together in the print line. Oops. So we'll recompile. And go ahead and run. And there we go. We've got them concatenated together. Now for the purposes of this example, I'd probably want to put a space in there so that the name wasn't all blended together. For your project, because you're concatenating a file name and that output file path, you probably want to concatenate those together without a space in there to make it work correctly. And in that case, what you would probably want to do is create a variable maybe to hold those two things. So maybe that string output file path, or in my case, in order for this to really make sense, I would call that full name. And then later on in my program, I would use that however I want to use it. In this case, we'll just output that here. Oops, sorry guys. Extra parenthesis hanging around from previously, so we'll get rid of that. we go. So same output, just now here I've got a variable to hold those. So hopefully that helps solidify a couple of things about the interface, how we get the properties, and how we can pull those two different fields together, two different variables really together into a single one and display that. I also wanted to take the opportunity here just to show a few things that can go wrong. So sometimes we forget to do the import, and that's something that I find myself forgetting all the time. But if a class exists or an interface exists in a package outside of the package that I'm in, not in Labs 2 in this example, I don't have access to that thing. I have to tell the runtime and actually the compiler where to find a particular class. So that's why I need that import statement. So as I'm going to compile here, think about, will I see an error now as I'm compiling, or is it a runtime error? So I won't see that until I actually run the script. So think about what you expect to have happen here. And we do get the compiler error. There's compiler error in two different places. One, where I'm referring to the class, calling the, implementing the properties loader, and the message is cannot find symbol, and the symbol that it's looking for is the properties loader. So the compiler in general doesn't lie. If it says it can't find something, it's because I probably forgot to tell it where to look, or I've typoed a name. Those are kind of the most common reasons for not finding a symbol. I forgot to define it. I forgot to tell the compiler where to find it by doing an import. All right, so we can fix that up. And the other thing that wasn't found was the method load properties, right? So the way that the compiler works is when it sees load properties here, it's going to look inside of this file, doesn't find a load properties method, and then the next place it would look would be on any classes, superclasses or interfaces. Well, it couldn't find that, so it's not going to find the load properties either. So a recompile here, we should be back to good. Another thing I want to demonstrate is that we have to be careful with the names of the properties, right? These are case sensitive. We're dealing with Java, and Java is always particular about case. There are some languages that are a little bit more forgiving with that. Java is not one of them. So it's going to do an exact string match here on first name, all lowercase. Now again, think about, when does this check happen? Is this going to happen at compile time? Is it going to happen when I run the application? And what kind of error am I going to see? So let's go ahead, oops, and we'll build. And the compile happens just fine. So at compile time, the compiler is checking for things like interface names, class names, method names, and the scope of things, but it does not specifically look at strings and try to evaluate them. So it's not actually running this code, it's doing more checking to make sure it knows what things are. So when this is compiling, it's basically just saying, okay, well, there's some string there, I don't care at this point what that is. It's the runtime that may care about that. So let's run the program now and see what happens. And again, think about, am I going to get an actual error? Is something else going to happen? So when we run, there wasn't an error. I didn't get a null pointer exception. What I got was just null. So the property here, when it was read in, it created an object reference, but there wasn't anything that was actually pointing to, because first name isn't a value in my properties file. First name with a capital N is. And so that's not found, so the property first name is actually null. So that's what we're seeing. We didn't see a null pointer exception, but we're seeing output of null. So watch for that in your program. It's pretty common as we're starting to learn how to work with properties that we end up with a typo in there and see a scary null and think something really bad is happening, when in fact it's just the fact that the runtime can't find that particular property, right? All right, so let's fix that back up. And again, I'm going to just compile and run again to make sure that I am back to normal and haven't made any other errors in there. And that should have worked. Let me compile again here. Oh, I haven't saved the file, right? Just before I clicked, you could see the blue was there, indicating that I hadn't saved the file. Got to make sure we save. I'm demonstrating all the mistakes today for you guys. All right, and now we're back to what we expect. One more thing here that I'm going to just comment this out and remove demo. Will this work? So think about, again, if you think it won't work, where will we see a problem? Compile time, run time, or there'll be some other kind of error in our output. So let's save that, compile. And we've got a compile time error. And that compile time error is here on line 10 of the props demo class. So the caret is pointing to load properties, and the message is non-static method load properties, taking a string, cannot be referenced from a static context. Now, remember back to the end of first semester Java, we learned about the final keyword and the static keyword. And the static keyword means that a method can be run on the class itself. We don't have to instantiate a props demo in order to run the main method, right? And that's how main methods work. That's why they work, is because they're static. So since day one of our Java learning, we've always written that main method as public static void main, meaning I can run this method without instantiating a props demo. Now, the load properties, that's an instance method. So just a regular old method I would call an instance method, meaning I have to have an instance of some object in order for that to run. So that's why we need to do this business of instantiating the object and then calling load properties on that object reference variable. Now that's not the case anywhere else where we're outside of a static method. So you generally don't need to instantiate a class inside of itself like this anywhere except when we're kind of trying to do something in an educational scenario or maybe a testing scenario where we want to run some code inside of a main method. It's pretty unusual that we would really do this in the real world. For demonstration purposes, it works great because I've got a single class that I'm talking through and we don't have to do a lot of flipping around to show different stuff, okay? So this technique generally used only for demonstration purposes in a main method. All right, so let's save that again and rebuild. Compiler error should go away and we are good to go. So I think hopefully that was helpful, demonstrating the interface, demonstrating some things about properties, and then also stuff that can go wrong. And sometimes by generating those messages and thinking about what's causing it can help when the error happens and you didn't cause it on purpose. Hopefully you can kind of use this as a way to interpret those error messages and understand what's going on and fix your code. That's what we spend a lot of our time doing as developers, and I want you guys to get really comfortable with that. So things going wrong, compiler time, runtime, totally normal. Get good at fixing that and you'll be a great developer. All right. On to the lexical density analyzer. So this is in project 2, and the lexical density analyzer is an optional part of project 2. So you have options. You can choose to skip the largest token analyzer or the distinct token counts analyzer and instead build the lexical density analyzer, or you can build all three and then the lexical density analyzer becomes an extra credit option. So I want to talk a little bit about what lexical density is, and I've got a link here for you for reference. Essentially, we're talking about a lexically dense sentence has a lot of words that have meaning, that add meaning to the sentence. So in this case, the quick brown fox jumped swiftly over the lazy dog. There's a lot of words in here that really add meaning to that sentence, but there's a few that aren't all that important. The, over, the. A lot of times those prepositions and pronouns are the words that really don't add quite as much value. It certainly adds meaning, but it doesn't add quite as much as some of these other words like jumped and swiftly. Another example here, she told him that she loved him. Told and loved are the lexical words, and the other words in black here are non-lexical. So in order to figure out what lexical density a particular sentence has in this case, we can count up how many words we have. There's 10. and 7 of them are lexical words. So 7 divided by 10, we've got 70% density in that particular sentence. Down here, the percentage is a little bit different. We only have 2 out of the 7 words that are lexical, and so the lexical density there is 28.57. So your job is to build an analyzer that will take in tokens and then evaluate those tokens, each one, determining whether or not that particular token is lexically significant. Or is a lexical word or a non-lexical word. Now, if you think about the English language, there are many more lexical words than non-lexical words. So your attack on this should be to build a list of non-lexical words and then compare a token coming in. Is it non-lexical, or is it lexical? And keep account of those. And then at the end of file processing, when there aren't any more tokens and when we decide to generate the output file, then you can do some simple math to get the percentage here. So if you use a little bit of Google Foo, you should be able to find a good list of non-lexical words. You don't have to get crazy and build a database or anything like that. You should be able to accomplish this with the skills that you already have in terms of reading files and writing files. Very similar to the other analyzers, just maybe one added bit of complexity to it. So there are some additional examples down here along with the percentages. These will be good test cases for you to verify that your lexical density analyzer is working correctly. Now, that said, make sure that you test with some things other than this, because in this case, if you only had he, to, and the in your non-lexical list, these would all pass, but when we put the big file in, you'd probably have a pretty off percentage in terms of what I'm expecting. What am I expecting for lexical density on the big file? It's going to vary based on what your non-lexical word list looks like. I would expect you to fall somewhere in the range of 35 to 55% lexical density on the big file. Make sure you create lots of smaller tests to verify things are working as you expect. And that is part of the project, or a part of this analyzer. I don't have unit tests written for the lexical density analyzer, so that's your job. So to get the full 10 points of extra credit, you need to not only write the analyzer, but also write some unit tests that test and verify that every method in your lexical density analyzer works correctly. You do not have to use JUnit for this. We use the JUnit framework for the unit tests that you guys have been using this semester. You don't have to do that. That's a topic that we'll cover and get really good at in Enterprise Java. Instead, what you can do is just use the same technique that you use first semester Java to test your code. Use a main method, instantiate the class that you want to test, determine what the expected output should be, set up the variables or any information that you need to pass in that information into the method that you're testing, and then check the expected output against the actual output, and then output a message that says, yes, this particular test passes. So remember, the output of a good unit test is success or a failure, or a pass or a fail, not some number getting spit out on the screen. Say lexical density is 67. I don't know if that's the right number or not. So you should be programmatically checking to make sure that the value is what you expect and outputting a message as such. Now, it's not wrong to output the density was 67%, but after that, then make sure you're putting this is the expected answer, test passes. So you really want to ultimately have that pass-fail message. All right, so that's the lexical density analyzer. And then going back to my notes here, one of the other questions that had come in was, we've got these big project specs and this big, recipe for building the project. How do you parse and process all of that and come up with a good plan of attack? And honestly, this is something that's going to depend on you. So I'm going to toss out a few recommendations that have worked for me and others that have been recommended by students, some of them your peers, and I'll share those, and then hopefully that will help you form your own process for working through project specs and building out a project. So first thing that I like to do when I get a big project in school or even at work is to kind of understand what the project is asking me to do, and if I have the time, let that kind of sink in. So my approach to project 2 ideally would be watch the video that explains it, right? I've got a video out there for that. And then read through the project specs. Read through it once or twice, and then let that sink in. Let your brain work on that. You know, maybe you don't pick this up until later in the day or even the next day. Your brain is working on that, and you're working on it, and you're processing it. And during that time, you might think, oh, you know, I don't quite understand this thing. Or you might be starting to solve some of the problems, some of the calculations that you might have to do. You might think about that, rather than sitting down right away and having to fight through understanding the specs, fight through the syntax and the logic all at the same time. Kind of breaking those out can help you be more successful with this. Another recommendation from a student is, as you are reading through the specs, put those specs into the comments in your project, either at the class level as a comment or at the method level as a comment, and think of that sort of as your task list of things to do. So I could copy a couple things here, and let's imagine that I've got my file analysis class open here. I could add into my comment a to-do item and then those specs. And I have a couple to-do items here. And the nice thing about doing it this way is, number one, I don't have to context switch now between the website and my code. I have all of that stuff right in my code. And the other nice thing about using a to-do is that in Atom, we can see a list of the things that we've listed that we have to do. So for those of you who like lists, this to-do view works really, really well to show you here what those different things are that you need to be doing, okay, that you need to be working through. And it highlights those. You can jump to them pretty easily, so you've got a nice task list here for that. And that will work in any of the different files. It doesn't have to be Java code. It could be your JSPs. Anywhere that to-do comment is showing up, it'll show up in your list here. Another tip from another student was take notes as you are going through the specs and put this into your own words. So these are my words. They make great sense to me, I think, but they don't always make sense to you, and it may not be the language that you understand the best. And so by writing that down and putting it into your own words, that may help you really understand the specs and what they really mean, what the different steps are. That said, you might actually sit down and prep code this or pseudocode this, work through some of the logic, particularly the more complex parts where maybe you're determining what the largest tokens are. There's a little bit of logic that might have to happen there. Do that on paper before you even open up your Java editor and start writing code. In that way, you've broken out the task of figuring out the logic versus figuring out the syntax to do that thing. So prep code on larger projects like this can be very, very effective. So think about that. Remember what we did in first semester, and see if that doesn't help you, at least with some aspects of the problem of the project, by writing that down. Ask questions. So if you get stuck, you don't understand something, ask. So I always feel really bad when a student submits a project and they're like, well, I didn't know if you meant this or this, so I did it this way, and then it turns out that's not the expectation. Just ask, and that's what you're expected to do in the workplace as well. If a spec isn't clear coming in from a business partner, you should be asking for clarification, not just taking a guess at what the spec means and then having it wrong. So ask questions, ask lots of questions in Slack. Your peers are there to help. I'm there to help as well. And I love seeing you guys helping each other. It's a great thing when I wake up in the morning and I see that there were 30 messages in Slack, but there's nothing for me to do because you guys have helped each other out. So be sure to be very helpful out on Slack, and don't be afraid to ask questions. Everybody has probably the same question you have or will have, so don't be shy about asking that. All right, that is it for now. Hopefully those 3 topics were helpful for you. Please reach out if you have any other questions. Otherwise, we'll see you next time.